All right, so today we're going to talk about compound inequalities. So when we solve compound inequalities, we also have to take into account the word and or. So when I say and, what I'm referring to is an intersection. Okay, so for example, if I said, you know what, you can have a bag of chips and 5 cookies. That means you have the possibility of having both at the same time, correct? So when I say you can have this and this, that means you can have both. Now, with inequalities, that's why we would call it intersection, because that's where all the solutions will be the same. So let's take a look at example 1. It says translate the verbal phrase into an inequality, then graph the inequality. So it says all real numbers that are greater than or equal to -1 and less than 2. So it's referring to all real numbers less than 2. So what it's really important is that the key word here is the word and. And so you want to make sure that you write and between the two inequalities. All right, let's get to graphing this. So when I graph this, I'm going to get at -1, it's going to be a closed circle, so I need to draw in my number line. So let's do 2. All right, so I have a number line there. I'm just going to change my color here. So that means when I graph this at -1, it's going to be a closed point because of the equal part of it. So it says x is greater than or equal to -1. So that means I'm going to draw my number to the right, or my inequality to the right. Okay, because it says x is greater than or equal to -1. Then it says x is less than 2. So at 2, that's going to be an open circle. And it says x is less than 2. So that I'm going to draw my number line, or my array, to the left. So now if you look carefully, the intersection that you will see is actually located between -1 and 2. But see here, this is an open circle. So our solution is located in between these 2 points here. Okay, however, it does not include the -2. Okay, so when I graph this, it would not include the -2. So our solution is in between this. Okay, it includes -1, but not 2. So that means this is an intersection. And I can erase the rest of it because I really don't need the extra pieces, but you can visually see that this is where the intersection is located. Let's take a look at the next example. It says solve the inequality and graph the solution. So there are actually 2 ways to solve this, but I'm going to teach you the first way with the word and in between it. When you do this, you do need to have the and in between. So what I see here is I see a -5. Oops, wrong one. Let me move this up. Here we go. -5 is greater than or equal to y minus 8. Now that's one compound or one inequality that I see. And I also see, and notice I wrote the word and. It's really important that you write and if you're going to do this way. If you forget the and or the word or, you'll be marked off. So you want to make sure you write that down. So we have -5 is greater than or equal to y minus 8, and y is, so y minus 8 is greater than or equal to -7. Then we can solve for that. So I'm going to get 3 is greater than or equal to y, and notice I'm writing my and again, and we're going to get y is greater than or equal to 1. So that's your solution. So I'm going to go ahead and graph this to see what happens, and then I'm going to show you another way to solve. So I have at, let's go ahead and do 0, 1, 2, 3, 4, and 5. And I'm going to go ahead and graph these and see what happens. So y is less than or equal to 3, or 3 is bigger than all real numbers. So at 3, it's going to be a closed point, like so. And it's saying that y is less than 3. So that means it's going to go in this direction. All right, then we have y is greater than or equal to 1. So I'm going to go ahead and graph that. So at 1, it's a closed point as well. And it says y is greater than or equal to 1. So that's going to go in the direction to the right. So when you graph this, you can erase the parts that are not where the intersection is at. So I'm going to do that in a little bit. And so our intersection is actually in between these 2 points here. That's where I would see the answer. So at this point, I won't need this part of the graph so that you can see. So at this point, I can erase this line and see here is where the intersection is located. If I go back to the other one that we did earlier, I can also erase these lines here because we already know we only want where they intersect. We only want to know where they intersect, and that's where they intersect. So when I zoom out, you can see that the solutions are in between there where the intersection is located. Notice on this one, this is an open circle, close point, close. Now, I'm going to go ahead and zoom back in, and I'm going to show you how to solve this a different way. So here, this is only ands can be written in this form. Ors will never be written in this form. So if I was to solve for this, I'm going to add 8 to both sides, all sides of the inequality, the left side, in the middle, and the right. So we still have to make things balanced. So in the end, you get 3 is greater than or equal to y, which is greater than or equal to 1. This essentially is the same thing here. So, but you can write your answer in this form, or you can write your answer in this form. When you're writing in this form, we do like to write it in a certain way. We like to write the smaller number to the left. So it'll be y, and I'm going to read it backwards. So it'll be 1 is less than or equal to y, which is less than or equal to 3. Okay, that's just the same thing as me saying y is greater than or equal to 1, and y is less than or equal to 3. Same thing. So you have 2 ways of writing your inequalities, in this form here and in this form here. Let's take a look at the ors. Now with ors, we actually, instead of calling it union, like intersections are called, intersections are called intersections. Let's go ahead and look at the ors. When we looked at ands, they were considered intersections. Ors are called union. So when we're solving for this, it says translate the verbal phrase into inequality, then graph the inequality. So all real numbers that are less than -4, or, notice I wrote the word or, x is greater than -1. So when I graph this, I want to make sure that I have a nice number line here so I can, utilize that. So I'm going to do 0, -1, -2. And I'm going to graph each of these points. So we'll start with y is less than -4. So at -4, open point because it's less than, and it goes to the left side because that's where it's going to go smaller. And then I have x is greater than -1, so at -1, open point, and it's saying that x is greater than -1, so it goes in that direction. So our graph is going infinity in opposite directions, and the only solutions that will not exist is anything from -4 to -1. So this is where there's no solution in this, but our solutions are all numbers that are less than -4 and all numbers that are greater than -1, and that's where your solution is at. So your graph will look something like this. So when I look at the solution, I know that -4 cannot be a solution, -3, negative 2.5 is not a solution, -1 is not a solution to this inequality statement. Let's take a look at the next problem. So we are going to go ahead and solve this one. This is an OR. So ORs are left with the words OR in between. So please make sure you write OR. Okay, so we are going to solve for this. And we subtract 1 and then have -3h is greater than or equal to 6. Then we divide both sides. So when we divide by a negative, we do want to remember to reverse the inequality statement so that it is true. All right, so we're going to do another color for the right side here. So it says your answer is h is less than or equal to -2, or, and we're going to go ahead and solve this one. I'm going to add 5. Sorry, guys. All right, let me just try to erase this because I wrote it wrong. All right, so we have -2h is less than -12. And then we're going to divide both sides by -2. And we're going to get h is greater because we have to reverse the symbol to make the statement true. And that's 6. So let's go ahead and build our number line. So I'm going to need numbers between -2 to 6. So let's go ahead and see if we can do that. I'm going to go by 2's to help us out. So let's see. -2, 0, 2, 4, and 6. All right, so let's graph. H is less than or equal to -2, so that means at -2, it's going to be close point, and it's going to the left because we're saying all real numbers. So to infinity to the left of -2 is all your solutions, and to the right of that is going to be at h is greater than 6, so open circle at 6, and it's going to go greater to in this direction. This is your